Hello, I'd like to go over the Unit 3 test study guide. So just as a reminder, this Thursday, the 13th, will be Unit 3's test. And I've told the students there are several skills that will be on the test, including finding a fraction of a fraction. So another way of thinking about this is fraction multiplied by a fraction of a fraction. Multiplying a fraction by a whole number and multiplying a fraction by a mixed number. Dividing whole numbers by fractions. And dividing fractions by whole numbers. In addition to these skills, students will need to be able to draw diagrams that relate to these skills, as well as being able to determine what expression matches a given diagram. And most importantly of all, students will need to be able to read a situation or story problem and be able to make sense out of it and solve it. So that's going to mean understanding the situation enough to know whether to multiply or divide, and then figure out what their factors would be, or which number would be the divisor, which number would be the dividend. So I'm going to go through the study guide, and then I'm also going to give some additional examples, and I'm going to write some problems out and then ask you to pause the video if you would like to try to work those out before I do, just to give you an idea of whether you understand what's happening. So the study guide right here starts out with a diagram. Write a multiplication expression that represents the area of the shaded region. Explain or show your reasoning. So we have this shaded region right here, and we need to write a matching multiplication expression that we could use to find the area of this shaded region. So I always like to use the area formula as a reference when we talk about these types of problems. So the area formula requires us to multiply the length of a rectangle by its width. If we look at the dimensions of this rectangle, we actually see that it is a square. So each side is one whole in length, and so we can go down one side of this square to determine the length, and we can go across the top of this square to determine the width. So going down the side here, we see that this whole has been divided into three discrete sections. This tells us that the whole has been broken into thirds. One of these thirds is shaded in, and so the length would be 1/3. Going across the top, we see that the whole has been divided into 1, 2, 3, 4, 5, 6, 7, 8 equal sections, with one of those sections shaded in, so the width would be 1/8. Now we can use this length and width to build our multiplication expression. So 1/3 multiplied by 1/8 would answer this question. Notice the question does not ask what the area of this shaded region is. It simply asks for a multiplication expression. So even if this was the only thing a student wrote, this represents a correct answer. Now, everything else that I wrote is part of the explain or show your reasoning. So it's going to be important that along with an expression, students add enough detail to their answer to explain why they wrote the expression they did. Down below, these are simple computation problems. So students are more than welcome to draw a diagram if they need to. So in this case here, in A, we could draw a diagram split it up into fifths, shade 1/5 in, and then find 1/4 of that fifth, and extending these division lines across all the fifths shows us that this piece here is a 20th in size. So 1/4 multiplied by 1/5 is 1/20th. And I encourage students to use diagrams for these problems if they can't remember what the rule is. I don't want them relying just on rules because they're easy to forget. Many students who had worked out a rule for multiplying fractions after Christmas break had forgotten that rule. They weren't sure which numbers got multiplied. Did all of them get multiplied? Did only some of them get multiplied? So there was some confusion. But if they can relate the rule back to a concrete representation of what's happening through a diagram, a lot of times it's going to jog their memory. And so they'll remember, okay, I need to multiply the factors' numerators to get the product's numerator, multiply the factors' denominators to get the product's denominator. And so once this rule, so to speak, is understood, it becomes really easy to find the products of these last two expressions. 2 times 3 as the numerator, 3 times 4 as the denominator, which gives us a product of 6/12. Some students may recognize that 6/12 is the same as 1/2, but if they left the product as 6/12, that would be considered correct. C, we have 5/4 multiplied by 5/6. Again, all we need to do is multiply the two factors numerators and the two factors denominators, which gives us 25/24. Students could keep this product improper or simplify it as a mixed number. Both answers would be considered correct. So often when I first go over fraction multiplication, I have them think about it in terms of something like this. What would 1/2 of 1/3 be? And drawing a diagram I like to start off by modeling the fraction that's listed all the way to the right. It doesn't matter which order you draw these in, but when I think of 1/2 of 1/3, I first want to establish 1/3 and then find a half of it. But that's a preference. If students set out by drawing 1/2 and then finding 1/3 of that 1/2, they would end up with the same product. So it's not a major detail that has to be followed, but it's just my preference. So I have 1/3 here. I want to find half of it. Well, if I want to find half of something, I want to cut it into 2 equal pieces. So to determine what the product would be, I have to figure out what would the size of one of these pieces be. So imagining that I had, let's say, 1/3 of a coffee cake and I want to split it with a friend, that would be finding 1/2 of that third amount of coffee cake, so we would each get this sized piece. So to determine that sized piece, we need to think about how many of these pieces would it take to fill in the whole, okay? If I extend this division line across the other thirds, I can see that this piece is a 1/6 in size. So 1/2 of 1/3 would be 1/6. And again, if we follow the rule, so to speak, for multiplying two fractions, 1 multiplied by 1 is 1, 2 multiplied by 3 is 6. So students will not have to be able to draw a diagram to answer problems like this, but they're still going to need to understand the diagram to be able to answer questions like the first question here. So I'm going to write a few problems here, and after I'm finished writing them out, you may want to pause and see if you can solve these on your own. So if you want to pause now, there's 3 questions to try on your own. All right, so I'm going to go over each of these. 1/3 of 1/4. I'm going to start by drawing a diagram, and I'm going to start by showing 1/4. Now my diagram is far, far from perfect. Ideally, these fourths should be exactly the same size, but even a crude drawing like this can help students understand what's happening. I want to find 1/3 of this fourth, so I'm going to divide this fourth into 3 pieces. Next, I want to find what the size of one of those pieces would be. And I can see by examining the model, it would take 12 of these equal sized pieces to make up an entire whole. So 1/3 of 1/4 would be 1/12. Again, this model proves that we can use the rule multiply the numerators and the denominators of our factors to get our product. 1 multiplied by 1 is 1. 3 multiplied by 4 is 12. Students can draw models for these types of problems as well, or they can simply follow the algorithm that we just talked about with 1/3 multiplied by 1/4. So, multiplying the numerators 4 and 1 together, multiplying the denominators 5 and 2, we end up with a product of 4/10, or 2/5 if a student wants to simplify this fraction. Either product would be acceptable. And last, I'm going to draw another picture. So we want to find 1/6 of 2/3. So I'm going to start out by showing 2/3. I've split a hole into 3 pieces, 3 equal pieces, the best I can. I'm going to shade in 2 of those thirds. And then next I want to find 1/6 of those 2/3. So I'm going to break those 2/3 into 6ths. And I want to find what 1/6 of those 2/3 would be. So 1/6 of 2/3 means I could consider 2 pieces, and each of these pieces are going to be an 1/18 in size. So if I extend these division lines across that last third that wasn't shaded, I can see that there would be 18 equal pieces that make up the whole. And so 1/6 multiplied by 2/3 is 2/18, or 1/9 for students who prefer to simplify their answers when they're fractions. All right, so that is the first page of the study guide, and you will notice that at the very bottom of each page of the study guide, I have answers. So students can work the problems out on the page and then check to see what the answers are, or see what the answers are first and kind of work backwards from there to make sure they understand how to arrive at those correct answers. On the next page, we have another diagram, and we are asked to write a division expression that represents the shaded piece of the diagram, and then we're asked to write a multiplication expression that represents the shaded piece of the diagram. So let's figure out first what happened to the diagram before we divided this piece into 4 equal pieces. So if we were to remove these dividing lines here in this shaded part, we can see that this whole has been divided into 3 equal pieces. So each of these sections here represents 1/3 of the whole. And if I look at 1/3, I see that this 1/3 has been divided by 4 equal pieces. So a division expression then would be 1/3 divided by 4. Next, we want to write a multiplication expression that represents this situation. Well, if we go back to the first page here, and when we had a multiplication sentence or expression like this, 1/4 times 1/5, remember that one of the ways I thought about it in the beginning was finding 1/4 of 1/5. So if we go back to this diagram, I just found 1/4 of 1/3 here, meaning the matching multiplication expression is 1/3 multiplied by 1/4. So I want to draw a couple more diagrams like this, because coming up with a multiplication and division and multiplication expression for the same situation may be a bit confusing for some students. So starting out with a diagram such as this, and I'm drawing in front of you, it may be a bit easier to see what I'm doing. So this one below the diagram here is just informing us that this represents one whole. It could be one whole anything, but in the problem it's 1. Now it becomes clear that I've divided this whole into halves. Now it appears that I have taken 1/2 and divided it into 4 equal sections. So a division expression is going to start with dividing 1/2 by something. And if we were to shade one of these sections of 1/2 in, we could write the division expression 1/2 divided by 4. A matching multiplication expression, and when I say matching, I don't mean it matches the division expression, because the expression will be different, but it would still match the situation diagrammed above. And because both of these expressions diagram the situation above, they should end up with the same answers. So same product, same quotient. So the multiplication expression, again, if we think of this as 1/2, we've found 1/4 of that 1/2. which we can represent as 1/4 multiplied by 1/2. Now, 1/2 divided by 4 is 1/8, and 1/4 multiplied by 1/2 is also 1/8. So if we get the same answer, and that answer matches what we see here, then we know that we have the correct expressions. So in order to see that 1/8, I'm going to divide the other half into 4 equal pieces as well. And then you can see now that across the entire whole, it's been divided into 8 equal pieces, meaning that if 1 out of the 8 is considered, then 1/8 is the correct value. So I'm drawing another diagram here, and after you've had a chance to watch me draw it, I encourage you to pause the video and see if you can write first the multiplication expression, and next a division expression. So I've completed the diagram. So I encourage you at any point to pause the video and see if you can answer the 2 questions. Okay, so now I want to go over first the multiplication expression. This whole has been divided into thirds. So this piece right here is 1/3. This 1/3 has been divided into fourths, meaning that we found 1/4 of that 1/3. And that's our multiplication expression, 1/4 of 1/3, which equals 1/12. Next, our division expression. Well, we know that this section here represents a third, and this third has been divided into 4 sections. So 1/3 divided by 4 is the division expression that matches this situation. And 1/3 divided by 4 also equals 1/12. And just like we partitioned this third into 4 equal sections, we could do the same with the rest of the thirds. And that'll show us that our whole can be thought of as twelfths, or 12/12ths, and one of these twelfths is shaded in, so 4 multiplied by 1/4 multiplied by 1/3 is 1/12, and 1/3 divided by 4 is 1/12. The next 3 questions are simple computation problems, and in each we're dividing a fraction by a whole number. Many students are aware that the answer can be found by multiplying the whole number by the denominator, but often struggle to determine whether the answer in this case would be 15 or 1/15. And answering that question really, drawing a diagram really helps to answer this question. So if we draw 1/3, which we've done a couple times already in this video, we now want to divide that 1/3 by 5. So we're going to divide the 1/3 into 5 equal pieces. And then we want to figure out how much of the whole one of these pieces would be. Well, I think we can tell by looking at this diagram that 15 is not a reasonable answer because this entire diagram represents 1. The shaded part represents 1/3 of a whole, and 1/5 of that third is even smaller. So we're talking about a number here that has to be less than 1. 15 is much larger than 1, so 1/15 is the correct answer here. So while many students have picked up that there's a pattern that exists, and that's a good thing, they struggle when they get to this part. So 1/3 divided by 5, 15 or 1/15. A diagram helps, and just common sense helps. If you start out with a number less than 1 and you divide that number into smaller pieces, the quotient should also be less than 1, not more than 1. So recognizing then that when we divide a fraction by a whole number, we should get a quotient smaller than 1, then we can use that relationship that exists between the denominator and whole number. 6 times 4, which is 24, and we know the quotient of 1/6 divided by 4 is 1/24th, and not just 24. 1/8 divided by 3, again, we know that our quotient is going to involve the number 24 because 8 multiplied by 3 is 24. But because we're talking about a quotient that has to be even less than 1/8, 1/24th is the appropriate quotient. All right. So here we get to a question that really tests students' ability to understand a situation and be able to model that situation with numbers and expressions to be able to solve it. So the situation we're given here is 3 friends share 1/2 kilogram of cherries. We need to write a division expression that represents the situation, a multiplication expression that represents the situation, and then finally we need to answer how many kilograms of cherries did each friend get. Explain or show your reasoning. I wrote above here, a tip is to draw a diagram. I always encourage the students to actually picture what's happening in their mind, though. Imagine the 3 friends. Who are the 3 friends? Name them. Is it you and the 2 people you sit with at your table? Is it you and your mom and your dad? Who are these people that are sharing the cherries? And then try to picture the cherries. Have you ever seen a bowl of cherries? Is it a basket of cherries? And imagine dividing those cherries equally so that everybody gets an equal share. And then you can draw a picture to help you really understand what's happening. So what I'm going to do is I'm going to draw just a simple rectangle here. And if the rectangle was shaded all the way in, that would mean I would have 1 kilogram of cherries. But that's not the case. The problem says I only have 1/2 of a kilogram of cherries to share. So here's 1/2 a kilogram of cherries. And I want to share this 1/2 of cherries with 3 people. So I want to divide the amount of cherries I have into 3 equal pieces, right? And maybe you even name, like I said before, you name the people. So maybe, mom gets a piece or a part of the cherries, dad gets part of the cherries, sister gets a part of the cherries, okay? And then you can even label these parts. So this is mom's part, this is dad's part, this is sister's part. Okay, well then, what division expression is being modeled here? Well, we started out with 1/2, And then what did we do? We divided 1/2 by 3. And that makes sense because we have two things really in this problem. We have 3 friends, we have cherries. We want to make sure we're dividing the part of the problem that makes sense. It doesn't make sense to divide friends, it makes sense to divide cherries between the friends. So 1/2 divided by 3 is the division expression that matches this situation. Next, we want to write a multiplication expression that matches this situation. Well, again, what did we start out with? Well, we started out with 1/2 of a kilogram of cherries. And then what part does each person get? Well, they get 1/3 of that half. So 1/2 multiplied by 1/3 would be a multiplication expression that matches the situation. And then we simply solve to figure out how many kilograms of cherries each friend got. Well, if I divide both of these halves here into 3 equal pieces, and let's say I just consider what size piece mom gets, well, we can see that's 1 piece out of 6 equal pieces required to fill in a whole, or the whole kilogram of cherries, if there were a whole kilogram of cherries. So this would be 1/6 kilograms for each person. All right. The next question. And again, the key here is to read the situation, read the problem, and make sense out of it. And really to picture it in your mind, draw a picture of it. Even kind of acting it out sometimes helps. And then choosing the correct operation to use and understanding the role of the numbers in the problem. So this situation tells us that a trail is 3 1/4 miles long. May walked 1/3 of the trail. How many miles did May walk? Explain or show your reasoning. So, let's say I had this trail. Okay, it's pretty long. It's 3 1/4 miles long. So it's definitely a trail that's not going to take me 5 or 10 minutes to complete. There's a starting point and there's an end. And, maybe there's some trees and maybe there's a pond or a lake or, there's all kinds of things to see between the beginning of the trail and the end of the trail. But May doesn't walk the entire length of the trail. She only walks 1/3 of the trail. So if we were to divide this entire distance into thirds, she only got this far. So maybe in the future she'll walk the whole trail, but in this problem she only walks just one part out of 3 equal parts. So what this tells us is she doesn't walk the full distance. So our answer here to the question, how many miles did May walk, should be less than 3 1/4. So if we think about this kind of diagram right here in relationship to, say, the diagram that we looked at here, we could think about this using multiplication, and we can think about this diagram using multiplication as well. So if I were to redraw this so that it looks more like the diagram I just went back to show you, we'll draw this nice straight sort of straight diagram. And the whole diagram is going to represent the total length of the trail, which is 3 1/4 miles. And then because May only walked 1/3 of that trail, We're only interested in the value of this amount right here. Well, I can multiply these two numbers here to find the answer. So, because what I did is I took the whole, right, and divided it into 3 parts. Now, I could divide 3 1/4 by 3, but I'm going to choose to multiply 1/3 by 3 1/4. And I would recommend students doing that for this test as well, because it's a bit more straightforward, and we haven't learned how to divide mixed numbers by whole numbers yet. So multiplying a mixed number by a fraction here, it's going to be important that we remember we want to make sure every part of this mixed number is multiplied by 1/3. Many times students will multiply one part of this mixed number by the other factor, but not both. So we want to make sure that we multiply the 3 by 1/3 as well as multiplying the 1/4 by 1/3. So if I rewrite this problem as 2 separate expressions, 3 multiplied by 1/3 is going to give us 3/3 or 1 whole. 1/4 multiplied by 1/3 gives us 1/12. And then we can simply add these two partial products together. So 1 plus 1/12 gives us 1 1/12. And if you remember when we first started talking about this problem, after kind of thinking it out, we can see that this distance here, or represented in this diagram, this distance here, is going to be less than the total distance of 3 1/4 miles. But 1 1/12 miles is certainly less than 3 1/4. So this does make sense. So I want to conclude the video with a couple more examples of multiplying a mixed number, such as 3 1/5, multiplied by a whole number, such as 2, and a mixed number multiplied by a fraction, such as 1/3. Go ahead and pause the video if you want to try these on your own before I go over them. All right, so the first thing I'm going to do is I'm going to talk about this problem here. So this problem can be interpreted as 2 groups of 3 1/5. So one way we could solve this problem is repeated addition. Simply add 2 groups of 3 1/5 together, and that would give me 6 2/5. Now another way you could solve this is by going back to a strategy that's been used with whole numbers, which is the area model. You can break up the mixed number into its whole and fraction parts. So 3 here, 1/5 here, and then multiply each part of this factor by 2. And again, add the partial products. And so 6 2/5 we also get once again. Or you could work this problem out like I did the last problem we went over on the study guide. We can make sure that both parts of the mixed number are being multiplied by the other factor. So 1/5 multiplied by 2, and 3 multiplied by 2. 1/5 multiplied by 2 is 2/5. 3 multiplied by 2 is 6. Add your partial products, and you again end up with the product of 6 2/2. Or I'm sorry, 6 2/5. All right, dropping down to a mixed number multiplied by a fraction. So this was more similar to the last problem we did about the hiking trail. So again, we can think about making sure both parts of 3 and 1/5 are multiplied by the factor of 1/3, which would mean 1/5 multiplied by 1/3, and 3 multiplied by 1/3. 1/5 multiplied by 1/3 is 1/15. 3 multiplied by 1/3 is 3/3. We know 3/3 is 1 whole. Add your two partial products. 1 plus 1/15 is 1 and 1/15. You could also use an area model or an array model, depending on how you like to name them, by first breaking up the factor of 3 and 1/5 into 3 plus 1/5. And then multiply both of these factors by the other factor 1/3. 3 multiplied by 1/3 is 3/3, or the number 1. 1/3 multiplied by 1/5 is 1/15. Add your partial products. You end up with the same product we did before. And it's a bit harder to think about this problem in terms of repeated addition because you do not have a whole number of groups here. So you could think of this problem as you have 1/3 group of 3 and 1/4. But working it out using repeated addition like we did up here is not going to work too well. So these strategies here are probably students' best bet when they're multiplying a mixed number by a fraction factor. So I hope this video helps. I'm going to be providing students with a lot of different review opportunities starting tomorrow. Remember, the test is Thursday, 13th. And email me or message me on Remind if you have any questions. I hope this helps. Thank you.